So, dear students, we have started the molecular spectra. In this, we have studied what is meaning of electromagnetic radiation. Today, we will learn about the number of energy levels, that is the electronic energy level, rotational energy level, and the vibrational energy levels. Before going to these levels, we have to know that the energy of a molecule. Okay, energy of a molecule we can given as it will be equal to translational energy and plus internal energy. The components of or constituents of internal energies are electronic energies. Okay, that is the internal energy made up by these constituents, that is electronic energy plus vibrational energy and last one is our rotational energy. Okay, as said by Planck, the internal energy is quantized and also its constituents, that is the electronic energy levels, vibrational energy levels, and the rotational energy levels also quantized. Quantized means energy levels. If you that molecule has the energy, it has the such types of energy levels is there. Okay, energy is not made up by the continuously. Okay, energy levels is not made by the continuously. In a molecule there is, if suppose it is a rotational energy level, first rotational energy level, second rotational energy level, third rotational energy, fourth rotational. Okay, like that there is energy levels is present in molecule. Therefore, energy from a molecule is radiated in the form of quanta or bunch of the energy. That bunch of energy is called as the quanta by the Planck. If suppose if a source is there, you heated that source radiate energy in the forms of the packets. Okay, and each packet has the some certain energy, and it is mu is the frequency and h is the mu1, h mu2, h mu3. Okay, these are the frequency associated with this bunch of the energies. Okay, energy is radiated in the form of bunch of packet, and each packet has a particular energy and particular frequency is given by the Planck. And in a molecule the energy levels, okay, these energy levels is also quantized. It is first energy level, second energy, that energy level is not continuously is there. Energy levels is the quantized energy levels is present in a molecule. Okay, Planck said internal energy is quantized. Okay, other way we can say quantized energy, you can say shown by the steps. Okay, energy is radiated in the form of steps, and this is, if energy is radiated like that, means it is a continuously energy continuously radiated, and but like that energy is radiated in the form of packets. Okay, therefore by using these we can say that internal energy is also quantized. Therefore its constituents is its internal energy made up by the electronic energy, vibrational energy made up. Your molecules is due to temperature, it's vibrate. Okay, that molecule will be that, if suppose molecule is there, that molecule is vibrating. Okay, like that in backward, forward, that vibration is there. symmetrical vibration, unsymmetrical. There is number of types of vibration you have studied in also organic chemistry. Rotational means it's due to rotation of a molecule. The energy is associated with that particular molecule. Electronic energy means due to excitation of the electrons from the levels, the energies arises is called as the electronic energy. Okay, therefore, internal energy is quantized, electronic energy is also quantized, vibrational energy, all kinds of energy is the quantized energy levels. Now, we are now familiar with the energy. There is the levels is the presence in a molecules where excitation can be takes place. Electronic energy levels is higher. The spacing of the levels is the higher, and the higher energy required from one level. Excitation of one level molecule to the other level is higher energy is required. Okay. Then vibration energy levels, there is a its energy differences or spacing of the energy levels is the less than the electronic energy levels, and your last one is the rotational energy levels. Is again spacing of the energy levels is very small, and very small energy required for the transition. Okay, this we will use for the discussion or for explaining the energy levels later on. Now, if for sake of convenience we will study the absorption spectra and the emission spectra. If we know that if there is the energy levels, if suppose first is the E1 energy level and the second one is the E2 energy levels. Okay, suppose the molecule is excited from E1 energy level to the E2 energy level, and during this this excitation takes place by the absorption of the energy, and then that energy level, that molecule excited from E1 energy level to the E2 energy levels, and that energy is given by the Planck's is equal to h mu energy is absorbed by this molecule, and delta E upon h is equal to your mu. That frequency is required. That frequency energy is required for the excitation of one energy level to the other energy levels. Normally we express our spectra. So suppose your vibrational spectra we express in the wave number. Therefore, if you divide frequency by the velocity, you also divide both sides, you divide the velocity, then it is equal to mu bar, and mu bar is the wave number, and wave number we can express in centimeter unit. Okay, therefore that kind of wave numbers will be appeared in the spectra. Okay, number of your frequency band is observed in your absorption spectra. That type of spectra is called as the absorption spectra, and the frequency is absorbed to excite from E1 energy level to the E2 energy levels is equal to delta E upon h. That much frequency is required for the excitation one energy level to the other energy level. That is our absorption spectra. Due to absorption, your molecule excited from E1 energy level to the E2 energy levels. Then second type of spectra is the emission spectra. Your molecule is already present at the E2 energy levels, and that molecule will radiate energy. It comes to the ground state by radiating energy, and this radiating energy is also delta E upon h mu. Something frequency is radiate due to it's already present in E2 energy levels. It emits the radiation after and come to the lowest energy levels, and it will also, that frequency is radiated also given by delta E upon h. That type of spectra is called as the emission spectra, due to it emits the certain kinds of the energy which is already present in higher excited state and come to the lower excited states by emitting frequency, and that frequency we can predict by using our detectors, a number of instruments there. Okay, like that way we have discussed the absorption spectra and what is meaning of emission spectra. Now our internal energy is said by Planck's internal energy is quantized energy. Quantized energy means there is a certain energy levels is there instead of continuous energy levels. Okay, there is a energy levels. Okay, like that way. If you suppose there is a building, in a building from first floor to go to the second floor you go to the third floor, and third floor you go to the fourth floor. Okay, like that way you will go from this to this step to this step. Okay, like that way energy, there is a levels of the energy. It is not continuously energy levels is there. Okay, energy levels is not continuously merged to each other. There is a certain quantized energy levels within the molecule is present, and we have to imagine it. Okay, we could not see with naked eyes that particular levels, but due to the radiation we have measured by using the detectors, we have predicted your molecule by absorption in a certain frequencies will radiate the energy. By absorbing this radiated energy, the energy absorbed by the molecule, it's absorb the particular frequency. Okay, it not takes the all frequency. It's only absorb the particular frequency when it match with that particular distance. Okay, that particular from even in first energy level to the other energy level, that particular frequency is only absorbed. Not all the types of frequency is absorbed by a molecule or the samples. Only that particular frequency is obtained, which is that energy levels is present in the molecules. Okay. Therefore, the internal energies is quantized, and it also its molecular energy levels. Okay, this internal energy is made up by the components molecular energy levels, their vibrational energy levels, and the rotational energy levels. Okay, the molecular energy level, there is a separation of our energy levels is higher than the vibrational energy levels, and rotational energy levels, there is a less spacing of the energy levels in rotational energy levels. Okay, higher energy required for the excitation of the molecular excitation from one energy level to the energy level, their vibration to change the vibrational energy level, one energy level to excite to the other energy level, less energy required than the molecular excitation. For the rotational excitation, for the change the rotational energy levels from one energy level to the other energy level, very small amount of energy is required for the excitation of the first state to the other state. Okay, therefore energy of molecular electronic you corrected electronic excitation. Okay, electronic energy levels, vibrational and the rotational energy level. Okay, electronic energy is higher than the spacing, vibrational energy is higher than the rotational energy. Okay, this you remember these things. Okay, but first the points is you have to remember is your energy levels is the quantized, there is the number of energy levels we have shown like that lines, and the energy absorbed by the molecule is the difference between two energy levels. If suppose from these energy levels molecule is excited to second electronic energy levels, the difference between these energy will be absorbed by that molecule, and then it get excited from first energy level to the other energy level. Okay, now we have cleared that electronic energy level is the pacing of lines is higher than the vibrational energy levels, and the vibrational energy levels is pacing higher than the rotational energy level, because electronic energy for the excitation is higher energy, vibrational energy require less energy than electronic, and rotational for the excitation you will require the less and less energy than these two energy levels. Okay, we will try to draw these energy levels. Okay, energy is increases to this side. Okay, therefore your vibrational energy level, second vibrational energy level, third, fourth vibrational energy level, and okay, that is your V1, V2, V3, and the V4 is there, and in between these two there is a rotational energy levels. Okay, in between these rotational energy levels. Okay, in between the rotational energy level. If suppose we given the name to the R1, R2, R3, R4, okay, R4 like that, so on. Okay, and if E dash, this is E dash, second energy levels is first your vibrational, and the vibrational, and in between the vibrational there is a rotational energy levels. In between there is a rotational energy levels is present. Okay, in between there is a rotational energy level is the present. Okay, this energy levels, if you consider mu dash, this is a mu double dash. Okay, if you instead of R you will represent your rotational energy level J, J1, J2, and the J3. Okay, you shown like that the J dash and J double dash energy levels, E and E double dash energy levels is there. Okay, this all is about the electronic energy levels, and this all is about the electronic energy levels. Okay, and these are the lines. Okay, these lines are the vibrational energy levels, and in between the vibrational energy level there is a rotational energy levels is there. Okay, these are the energy level diagrams. Okay, in this you found that the difference between the electronic energy levels, okay, the pacing of electronic, this all is the electronic energy level, second is the electronic energy levels. In between the electronic energy level there is the vibrational energy levels, and in between the vibrational energy level there is a rotational energy levels. Okay, therefore in this case the pacing of the electronic energy levels is higher than the pacing of the electronic energy levels of vibrational, and later on the pacing of the electronic energy levels, okay, that is shown by the J, that is rotational energy levels is less than the vibrational energy levels. Okay, the difference between the energy levels, okay, the energy level, first electronic energy level to all this is the first electronic energy level, second electronic energy level. The difference between the energy between electronic energy levels is in round about 10 kilocalorie per mole energy is required for the excitation from one electronic energy level to the other excitation. And the difference between the vibrational, okay, the energy required for the excitation from one vibration level to the other, the energy is a few kilocalorie. Okay, not 10 kilocalories, so round about 10 kilocalorie energy is required for the electronic excitation. For the vibrational excitation 1 to 4, okay, around a few kilocalorie energy is required for the excitation from the first vibration energy level to the other vibration energy. And the energy required for, okay, such small energy is required for the excitation of the rotational energy, to change the rotation energy. It is 10 calorie energy is, okay, that is a higher 10 kilocalories, and a few kilocalorie energy is required for the excitation of vibration, and 10 calories less than the 10 kilocalorie. 10 calories, very few energy, very small energy required for the excitation of the rotational energy level. Okay, we have clear that the higher the energy levels of the electronic is the pacing higher than the energy levels of the vibrational is pacing higher than the our rotational energy level. So that we have this point is clear. First point we have clear that electronic energy levels, pacing of electronic energy levels is higher than vibrational energy levels, and which in turn higher than rotational energy levels. Okay, first point we have clear that electronic energy is higher pacing is there than the rotational vibrational energy level, and vibrational energy levels its pacing is more than the rotational energy. Very small pacing is you found in the rotational energy levels. Okay, now from first excitation of the electron, first electronic, if molecule is excited from one state to the other states. Okay, from one, okay, this is all about the electronic levels. Okay, this all bunch is electronic second. Okay, therefore from first electronic levels it excited to the other electronic level. Okay, for the electronic excitation, and this electronic excitation will be appeared on visible ultraviolet region. Okay, that the much more energy, visible and ultraviolet region is the higher frequency region than the IR, that is the your IR region is the 10 raised to 3 to the 10 raised to 5 nanometers, but your electronic is the your at 100 nanometers to the 400 nanometers to the 700 nanometer range is visible, and 10 to the 400 nanometers that range is the ultraviolet region is there, UV region is. Therefore your that spectra is obtained in a ultraviolet region. Okay, like that transition. Okay, that excitation is called as transition from one level to the other level. That excitation is called as the transition. Therefore, such transition you require the 10 kilocalorie energy is required for the excitation of the from the first electronic energy level to the other electronic energy levels. Okay. Now, if you want to excite the vibrational excitation, there are first level, second level, third level and fourth level. Therefore, for the vibrational excitation for transition, the transition is takes place from one vibrational level to the next vibrational levels within a electronic energy levels. Okay, first electronic energy level to the, it not excite from first view to the other view. It is excitation of vibration within that space, within only in this place takes place. That is the first in electronic energy levels. But electronic energy levels excitation is takes place from first electronic energy level to the other electronic energy level. But vibrational, for the excitation of vibrational energy levels, the excitation is takes place from one vibrational level to the other vibrational level within a electronic energy levels. Okay, and for the transition of the rotational energy level from first level to the other level, it is takes place within a vibrational energy level and same electronic levels within same vibrational energy level and within same electronic energy levels. That particular excitation from one rotational energy level to the other rotational energy levels takes place. Okay, like that. And your excitation of vibrational first vibrational energy level to the other vibrational energy levels takes place in IR region. And that region is the 10 raised to 3 to the 10 raised to 5 nanometers, and the excitation of the rotational energy. Okay, that line, small lines are the rotational energy. The excitation of the rotational energy levels is observed in far IR region or our that is a microwave region. That particular excitation takes place. Okay, the electronic excitation takes place via vibrational energy levels and in terms of via vibration energy. Okay, if you want to excite from one electron level to the other electronic level, there is a via rotational level, via vibrational level, via rotational, via vibration level, that electronic excitation takes place. Therefore, when you take the electronic spectra, there is also vibrational frequency you will observe there, and the rotational frequencies of the. Okay, actually it is electronic vibrational and the rotational spectra, and it is a very complex spectra is there. If suppose your transition takes place from one vibrational energy levels to the second vibrational energy level, that transition takes place via rotational energy level. Therefore, when you take the vibrational spectra, it is actually the rotational and the vibrational spectra, because vibrational excitation takes place via rotational excitation. Therefore, in vibrational spectroscopy, you will also observe some rotational frequency is there. Therefore, that spectra is also complex, not pure IR spectra you obtain. Okay, but for the excitation of first rotational level to the other rotational level in other frequency, if you avoid it, you can obtain the pure rotational spectra, and it is not more complicated than the molecular spectra, and it is not more complicated than the rotational. Okay, these are the energy levels. So very the few important things we have studied. Electronic energy levels pacing is higher than the rotational vibrational energy level, and later on it is higher than the rotational energy level, and the energy difference of two electronic energy level is the 10 10 kilocalorie, and the energy difference between two vibrational energy levels is few kilocalorie. Energy is kind of some 1 to the 4 kilocalorie energy. 5 kilocalorie is energy is required for the excitation from one vibration level to the other vibration, and 10 kilocalorie in the range of 10 calories. Okay, not kilo. In the range of 10 calorie energy is required for the excitation of the our rotational energy levels. Okay, like we have explained that the energy difference is for electronic is higher, then the energy required for the excitation is higher. Okay, we specified it, and again we specified for the excitation of one electronic level to the other electronic level, it takes place via from rotational energy levels and the vibration energy. If you excite the vibration energy level from one vibration energy level to the other vibration energy level, it takes place via rotational energy levels. Okay, like that way your electronic spectra is a very complex spectra than the vibrational spectroscopy, and the rotational spectroscopy is the simpler one, the electronic spectroscopy or the vibrational spectroscopy. Okay, this is all about our energy levels. I hope you get all this idea what is meaning of quantization of the energy levels, and how the difference of electronic energy, vibration energy, and the rotational energy we have studied today. I hope you all get these points. Thank you very much.